Okay. Good morning. Thank you for this opportunity. We are OpenStack Taka team. Today we excited to talk about transforming telecom Kubernetes in radio access network management. In this session, our team will cover the background of virtualization and OpenStack Taka solution and commercial use case. My part is explain why we are bringing cloud technology to the radio access network. Let's start with the fundamental question. Why does operator need cloud technology in telecom? Many of the audience are familiar with the NFV journey that started in Edge since 2013. Operator began virtualization their core network, moving away from proprietary hardware to code server. The shift brought great benefits: improved network quality through automated healing, traffic congestion management via efficient scaling, agility and operational efficiency using resource pool, which reduce each dedicated spare server. Docomo, who is Japanese biggest mobile operator, we started this journey early virtualizing the EPC in 2015. Docomo expanded to IMS, HSS, and other core network. This year, as this statement, Docomo achieved 100% virtualization for core network. The value was clear. It was not just CapEx reduction from using code server. It was about new operational possibility and efficiency gain the cloud technology enabled. The next step for operator is to maximize this value by extending to the LAN domain, which has considered challenging to virtualize. So Docomo developed an O-Cloud based on the O-RAN Alliance architecture, leveraging our core network experience. But there is a key evolution while the core network is VM based, but LAN is container based network. This brings even greater value. For example, faster healing. Containerizing application can restart in second level. It is minimize the operation time without redundancy. Next one is enhanced agility. Automation is more native and granular, such as from cluster creation to VNF deployment. And massive scale impact. The core network involves some 10 sites, but LAN involves some 1,000 level. Even 10,000 cell site. Improving operational efficiency at this scale through virtualization in a massive innovation the operation. The benefit was so in the core simplified operation as right side figure and multi-vendor VNF, better resource usage and CapEx OpEx reduction from dedicated decoupled software and hardware. Now operators bring these benefits to LAN, and we add more significant reduction of the on-site work and added new value to customer. This is background. Then, what does it mean to apply cloud technology to the LAN? As I said, virtualization technology has many benefits for operator. For example, cost reduction, vendor flexibility, rapid hardware and software update, and shorter lead time. Expanding LAN technology, virtualization to LAN. In essence, we are transforming thousands of the base stations from dedicated application into small standard data center using code server. This brings huge cost benefit and operational simplification. However, this shift also introduce unique VLAN specific challenge. For example, how can operator manage tens of the thousands of these high distributed small data center? This is one big challenge. Next one is how can operator reduce on-site work even further than what was possible by proprietary equipment. We need to more remote work by cloud technology. And the last one is how can we ensure the reliability and security of this highly distributed infrastructure. These three challenges there. So this is idea of the Docomo O-Cloud design to answer this challenge. The goal is to simplify the deployment and operation of thousands of sites through comprehensive automation. As you can see in this architecture, Docomo has the 4-layer. First one is public cloud. This is for central monitoring and management. Second one is central on-premise site. This is for backup and repository management, like a huge type of the storage. Third one is regional site. This is for aggregate the network and control function for larger network, like a central unit. Last one is edge site, where the base station function, like the distributed unit, actually run. The regional and edge sites are managed and monitored from the public cloud. In the O-RAN standard, the infrastructure management system is called the IMS as right side. And in the NFV, generic monitoring and operational function is called generic OM, leveraging path solution like Prometheus. In this case, central site has a path, and public cloud also has a path. With thousands of the site and application, manual operation are impossible. Automation is a critical one. Our O-Cloud and RAN application deployment is a two-stage automated process. Stage 1, this is O-Cloud deployment. We automatically install the physical server, register the inventory, and build the Kubernetes cluster. This is O-Cloud deployment as the first step. Stage 2, this is RAN application deployment. We register the resource for VNF, like VDU, VCU, then instantiate VNF. And remote feature is very critical, like remote health check, remote firmware update, remote reboot, and remote BIOS setting. These are key to minimize on-site work. This level of the automation was a mandatory requirement for large-scale nationwide O-Cloud deployment. As I said, it is 10,000 or several huge level of deployment. So while we could reuse the much of the know-how from our core network, the massive scale of the RAN revealed new specific challenge in our commercial deployment. We faced the three big issues. First one is out of memory issue of the STO. In large scale, STO has many registration in their memory. In this case, the service mesh management data in STO can grow significantly, then causing sidecar to run out of memory. Furthermore, initially, it is lack of the specific monitoring mechanism to act quickly and detect this problem. This is the first issue. Second one is massive parallel healing. With so many, like 10,000 VNF deployed, a huge disaster could trigger restart of thousands of functions in same time. The infrastructure must be robust enough to handle this healing storm. And last one is UI and manageability. Originally, a management dashboard designed for 100 level VNF, but now we need to 10,000 level VNF. In this case, we need a fundamental design for both performance and usability. In conclusion, the drive to virtualize the LAN is the next frontier in telecom transformation. It builds upon the proven benefit of NFV, but pushes the boundary of scale, automation, and operational model. The challenges are significant, but the payoff in agility, cost efficiency, and the new service potential is huge. Thank you. So next one is OpenStack solution.
Hi, my name is Yasufumi from NTT and PT of OpenStack Tech project. So then let's move on to the architecture and deployment of the umbrella system. So here is an overview architecture of the O-RAN standard architecture. So it is roughly divided into 3 parts. Bottom one is called O-RAN. It has responsibility for the underlying resource management, for example, VMs or containers or hardware resources also. And the middle one is called NF deployment, which is for responsibility for running the VLAN applications. So it consists of 3 components called VDU, VCU, and near RT rig. So VDU means distributed unit. It's mainly for processing the signal from for wireless communication, and VCU is means central unit, which is for controlling the VDUs, and RIC means intelligent controller for managing both of the underlying units. And the final one, on top of that, SMO is the key feature of the O-RAN standard model, which is for managing entire system. And it consists of OSS or NFV also. And for SMO, which is stands for Service Management Orchestration, is centralized system defined by O-RAN standard. And it is for managing the underlying components and also providing the high availability features such as fault management or performance management or configuration management or so. And it also enables the zero-touch operation and designed for scalable, cost-efficient, and nationwide deployments. And then we would like to show some more details about the DOCOMO use case using SMO and O-RAN architecture model. So within DOCOMO SMO, so Taka acts as a core open source component for VNF lifecycle orchestration, and it enables merge platform and merge vendor integration with seamless automation. And it's adopted in NFO component serving the VNF manager and partial VNF orchestration. Partial means not the whole features defined in the standard is not implemented in Telecom, but at least very required features already implemented in the Telecom. And it supports instantiation, scaling, healing, update, and termination. In other words, it means lifecycle management. And it also bridges OSS and multiple clusters and merge vendor VNF superior standard APIs defined in the O-RAN standard. And also supporting several templates such as hot or Helm sharp or VNF descriptor. So what advantage of Tacker? One of the most important advantage of Tacker is for providing the multi-vendor environment as a generic VNF. So for in our use case, we have very suffered from the difference between the multi-vendor specification, and it's ended up for taking so many cost or time or human resources also. And Taka is expected to largely reduce such a problem. So Taka implements VNF lifecycle workflows and provide unified XNFV compliant APIs, by which we can terminate the differences between each vendor-specific APIs also, and enabling advanced lifecycle orchestration with NFV and operation support system. And in Taka, it's adopted the infra driver for several features inside it. For example, managing containers, or so by using OpenStack or Kubernetes or Telecom selectively. And operator can develop configuration automation procedure for various types of VNF automatically during VNF lifecycle management. And now our activity is expanding over multiple open communities. In our case, in terms of Tacker, so we have contributed to XNFV standards as implementing its specification as reference implementation, and then we have made several feedbacks to the specification itself to improve something from our experiences. And also we have contributed to O-RAN Alliance for realizing the very sophisticated O-RAN systems by providing our code to for running something POC demonstration, and then feedback to the specification itself. And we have several contributions for the communities, and here is just an example of the list. So we have provided our POC demo for such as the event called Plug Fest or Plug Test from 2021, and we have made several contributions. You can see, Okay. Thank you.
Okay, so hello, my name is Toshiaki Takahashi from NEC, and I'm for the OpenStack Tacker contributor, and also I'm working for the O-RAN software community, that is open source community to achieve the O-RAN specific, so telecom specifications achievement. So today's my presentation is about the introduction of our commercial use case support using open source, such as OpenStack Tacker and Kubernetes. So first, this slide is explaining the overall of the component architecture, and I believe some of you, if you're familiar with the open-infra-related community, you know the name of these someone. For example, StannyX is of course open-infra communities, and Tacker. As we said, Tacker is an OpenStack component. So OpenStack Tacker, the next VNF, this is the OpenStack component. And also we use the Devtron. This is more Kubernetes side, CNCF side open source, but this is also open source communities output. So in short, we use all of these components are open source based, so we can, and of course you can use this architecture implementation because all of them are already published, and there are some documentation or also files are already available. I explained so briefly about each component work. So first, Tucker. We already explained. So what is Tucker is? Tucker is managing the applications lifecycle management. So application deployment, application termination, application healing, so recover the failure, or application scaling. That is the role of the OpenStack Tucker. And the second is Devtron, and currently Devtron is used for the SMO implementation. And Devtron itself is some workflow management and so provide the GUI to manage the multiple cluster and the multiple workflow. That is so Devtron basic capabilities. And we will use this Devtron as a SMO component. So Devtron is upper orchestrator, and so Devtron sends some requests to Tucker or Cloud to manage the cluster or application. That is the role of the Devtron. And the StarX, maybe some of you are more familiar with StarX than me, but StarX is for the edge side cloud management open source component. So StarX provides a Kubernetes platform or OpenStack platform, and also StarX can support some performance related hardware capabilities such as SRILV or ABDK and so on. So this is very useful for the RAN use case because StarX is for the edge cloud related open source component. And then we also use the Prometheus. So of course, Prometheus is a very general and a very typical monitoring software. So we are using the Prometheus to collect some metrics of application and or metrics of some infrastructure. So we can say that Prometheus, which is a very general and a typical monitoring system for the telecom use, also telecom use cases. So Prometheus is have some connection between Tucker or Devtron and of course Cloud. The telecom monitoring is possible using Prometheus. That is a important message from me. And the last is about just application. So currently our target workload, target application is called ODU. So that is an Open Distributed Unit. And this is a very typical. So this target application covers very typical use cases such as distributed. So of course very many applications should be deployed. And some of this ODU will use hardware accelerators such as GPU. So this is currently core network application does not use the GPU, but this ODU application requires the accelerator, and we should also focus on how to manage the accelerator. So these are brief role of the component. And of course we face some challenges with some issues, and the most big issue is regarding the accelerator management. So of course preparing the platform itself is very difficult because the accelerator is required, and how to configure the accelerator or how to configure the LPUs. So that is very difficult. And as I said again, this needs an automated system. So we should automated configuration of the GPU. That is a very important and very difficult challenges. And the second is maybe not only for the telecom specific, but of course if we try to integrate the multiple open source software, we face some integration challenges. So such as each component's configuration is required to integrate some other softwares, or we should create some total flow. So including the multiple open source softwares. And not included in the description, but the most big issue is regarding the authentication. So of course, there are several components, and so some components send the REST API to some other component. of course need an authentication to connect, so to send a request to the other component. So how to pass and how to manage such authentication information is a very big challenges for us, and maybe that is also explained at a later slide. So anyway, so we facing such issues, but finally we can provide some, for example, application package or some code flow. So to create the code flow, we create some script, or we also need to create some documentation. So all of the such output is already published, and you can already use such our output. Then I will explain what is the commercial typical use, practical use cases. Left side is, I said again, but we will manage the accelerator. We will use the accelerator, so we should manage the accelerator. So we should consider how to assign the GPU resources to the application. That is one of the typical use case. And the second is, so sometimes vendor provides some application with the virtual machine based implementation and the container based implementation. And as Yasumi-san said today, OpenStack Tucker can manage both container workload and virtual machine workload using the unified one API that is defined in standardization, NFV standardization. So upper SMO, upper orchestrator can manage both virtual machine and container using the one unified API. So ultimately we can deploy the hybrid VNF, so with the virtual machine based and the container based workload. And the right side is the most important, automated LCM framework. So automation is the most important topic. So we should, for example, we should set the monitor rule to Prometheus automatically, and Prometheus monitoring, and Prometheus send some alerts to the Tucker or SMO side, and ultimately automatic healing or automatic scaling are required. So how to achieve this automation is the most important purpose of our activities. Okay. And this is the overall of the use case. And so current our development, the assumption is SMO is pre-built and Starling X is pre-built. And for our development, cloud platform itself is also preconditioned. So Starling X based cloud and SMO is already built. Then first what we should do is OpenStack Tucker deployment in order to expose the NFV based API. By the way, how to deploy Tucker is we can use the OpenStack Helm, because OpenStack Tucker is OpenStack project. So just using the Helm, OpenStack Tucker can be deployed. And after Tucker deploys, SMO try to deploy the application using the Tucker's interface. So VNF package, using VNF package, send a request to the Tucker, VNF is deployed. And such scenario it starts to monitor the application. So details operation is send some request to the Prometheus to monitor virtualized applications. And lastly, if some failure is detected and some alarm is to the SMO, then automated healing request is sent to the Tucker and the application is healed. That is the overall of the scenarios. And I also explained the details, but very sure that today I have not so much time. But anyway, what we want to say is, as I said, this is a full automated system. So firstly, more upper side SMO, we are using the data. That is, send some request to the, so first upload package and create the application, instantiate application, deploy the application. And as I said, if the upper side try to create some fault management related subscription or performance management related subscription, then Tucker sends some configuration, not included, but the Tucker sends some configuration request to the Prometheus, and the Prometheus starts some monitoring. And then if, so use case, the flow 5, some failure is occurs, of course Prometheus can detect in some way. So for example, some metrics abnormalities detected, and some alert can be sent to the more upper side orchestrator. Then, firstly, Prometheus sent the alert to the Tucker first. And the important thing is, this alert is related to resource. So which Kubernetes code is abnormal, which Kubernetes deployment is abnormal. That is the information of the, from the Prometheus. And the Tucker is managing what application using which resources, Kubernetes resources. So for example, some virtual DUA is using some pod A. So such information is managed by Tucker. So if Tucker receives the resource abnormal information from Kubernetes, then Tucker can understand which application is currently abnormal. So Tucker can send the alarm to the upper orchestrator regarding which application, so for example, which DU. So this DUA is currently abnormal. Such information can be sent to the Devtron side. Then SMO Devtron decides so healing is required, so whether healing is required or not, and if healing is required, SMO side, Devtron side is send a request to heal the application. Heal the, for example, DUA. So that is possible using this architecture. And as I said again, this is already implemented, already developed, and already published. So you can use this system using the O-RAN communities API. And this is the last slide about the future plan. So as I said, accelerator support is important target, but currently still ongoing. And accelerator support standardization is of course ongoing, and that is called AAL in O-RAN standardization, so RAN-related standardization. So final goal is completely supports the automated accelerator resource management and completely supports the AAL-related specification or use cases. And the second is enhancing automation framework. So one important topic is auto-homing. Auto-homing means if the SMO receives the application deployment request, then automatically SMO selects the available O-Cloud in order to deploy the SMO application. So of course, application request includes some resource information, or for example, accelerator required or not, that is included in the request. Then SMO automatically selects the cloud and deploys the application. That is our auto-homing, and that is our plan. And the third is more intelligent auto LCM. So basic automated LCM is already implemented, but we also try to coordinate with the AI-related, more intelligent component. And the lastly, hybrid VNet. Basically, hybrid VNet is already implemented from the Tucker perspective, but so we believe maybe SMO side needs some more improved capabilities to manage both virtual machine and container management. So SMO needs some information about what is one's application set, including the virtual machine and container based, and send a request to Tucker based on such information. So maybe some SMO implements also required. So these four current our future work, and we try to complete our work by this year or next year. That is the current our situation. Okay, so that's all about today's presentation. So thank you so much. Okay, so any question? Sorry, but sorry, go ahead.
On one slide you showed the SMO located in public cloud, and you were using Devtron.
So Devtron is just open source, and that is not used in Docomo. Yeah, Docomo is only using the Tucker and the Kubernetes. That's all. And this communities actually is like some reference architecture implementation, and based on this implementation, Docomo try to implement. So maybe SMO is the other component, I guess. Yeah, but based on this reference architecture.
But I can put the Devtron as SMO in a private cloud as well, I guess. Okay.
Yeah.
And the accelerator card for the ODU is a common professional GPU card, or which kind of accelerator you are using there?
Intel. I forget the name. Sorry, I just forget the name, but the X100. X100.
X100.
Yeah, very typical. Yeah, accelerator.
Okay. Thanks. Thank you.
So any other?
So you mentioned a major challenge about the authentication among various services and components in the context of the zero trust, zero touch networks. This is a major issue. Also has been published by the ATSI community. So Have you considered blending some other emerging technologies to this in order to provide a solution?
Yeah.
Let's say technologies such as zero knowledge proof tools and other these technologies.
Okay. To be honest, try to is the current situation, and to be honest, currently fixed parameter is used in here, and especially for example between the SMO and local. So tuple is sometimes the server and developed at the client, and this client sends some authentication request to tuple client and the development server cases. So that is a complicated situation and need some solution. But as I said, currently the parameter is fixed parameters and try to use some solution, existing solution for authentication management.
Okay, thank you very much.
So any other questions? So sorry, yeah, 10 minutes over, but yeah, anyway, thank you so much. Yeah, thank you for your Thank you.